Hi guys, welcome to this next video in the algebra unit, and this time we're going to be looking at finding the rule using tables. We're still with our learning goal of being able to graph linear equations on the Cartesian plane, but at this you'll want to be able to determine the equation of a line from a given table of values. Okay, in our last video you would have seen the idea of a function being a sort of mathematical machine where we sort of shove x values in here that we know about, you know, 7s and 6s and whatever, they're all going in, and this is some, oops, should probably write that a bit neater. This is some function of x, okay, and we'd get out a whole bunch of y values, okay, and they might be like an 11, a 75 or something, like the 7 might be the 11, the 6 might become a 75, okay? Things would happen. And it would be usually in the form, what you guys have been looking at the moment, y is equal to mx plus c, okay? Now, what we're going to be doing now is, let's say we know that on this side the x was a negative 2, and we know that the y value was a 5 for that. What's going on in the middle here? Okay, so when we were looking at graphing stuff, we knew what the function was. Now we're going, okay, if we've got the points for the line, can we go backwards from that and find the function that created that line in the first place? Okay, so some key ideas for you to have a think about. So a linear equation will be true for all x, y points that lie on the line. Okay, so remember, a linear equation is just an equation that describes a set of points that all sort of lie on the line, that sort of goes all the way one way to the other. Now, linear equations, at least for you guys to worry about, should have this form y equals mx plus c. So whenever you're asked in a question or something to model a situation, you're going to want to try and model it something so it will look like y equals mx plus c. And in this y equals mx plus c, this m is your coefficient, and this x here is your variable, and this c here is your constant. Okay, or your y-intercept, that's another way of looking at it. Okay, but we're going to think about it coefficient, variable, constant. Okay, now when we've got a table of values like this is what we're going to try and turn. We're going to try and go from this back to something like that. Okay, you've gone one way, now we're going to go this other way. All right, now when we're trying to make our y equals mx plus c, the coefficient will be your change in y per your change in x. Okay, so that m is going to be equal to the change in y per change in x. Okay, now you'll see that get formalized a little bit more in the next video, but that's how I want you to think about it. Okay, so let's have a look. The change in y as we go, as x changes, so x is going up by 1 each stage, you can see that, negative 2, negative 1, 0, etc. Y is going up, down by 2. So it's going from 7 to 5, 5 to 3, whoops, 5 to 3, which is minusing 2 again, minusing 2, minusing 2. And so that means that for every one x value, we're going down 2 y values. So for this one, we have a change in y of negative 2 per 1x, which gives us a coefficient value of negative 2. Okay? Then the constant will be the y value whenever x is equal to 0. So we sort of have a look at our table of values up here. Here is where x is 0. So when x is 0, y is 3. Okay? So we could write that when x equals 0, y equals 3. Therefore, our constant c is equal to 3. Okay? Now that we've got those two values, we use it to construct a linear function in the form y equals mx plus c. So we're trying to create y equals mx plus c. Got y, m we found out before, it's here, negative 2. negative 2x plus our constant of of 3, and there we have it. There's our linear function. Okay, now there's two little issues that I want to go through where things can be a little bit different. Okay, so what about when the x values don't just increase by 1? So as you can see here, I haven't changed the y values, but I've made a new function by changing the x. So x is now going up by 2 each time. Okay, and our y value is decreasing by 2, as you can see from before. Now, so what this means is that, remember, m is equal to the change in x per change in y. Whoops, change in y per change in x. Is that what I set up above? Let's just make sure. Yep. So change in y over change in per change in x. So that's our change in y changes by negative 2 divided by our change in x, which is positive 2, which means that our m value for this one would be negative 1. So negative 2 divided by 2 is 1. Okay, so that would be a different m value. Now the other issue that can crop up is, what about when x equals 0 is not in the table of values? Okay, so I've changed our table again, that even though in y we've still got minus 2, minus 2, minus 2, etc., we've got this issue here of the x's, they're not going down. So x, where is x equals 0? Okay, we don't know where it is. Okay, it's down here somewhere, but what values are we going to have? Now, you could count back and things, but I'm going to show you a way if maybe you're too far away and you don't want to draw a giant table. So we can figure out the m value easily, okay, because we're still changing by 1 at the top here and by negative 2 down the bottom. So we know that m will be negative 2, similar to the example above. So we know, therefore, it will be something like y equals negative 2x plus c. So our issue is we need to try and solve for this c, okay? So what we do is we substitute, so sub in an xy from the table. Okay, so I'm going to choose this one, 7 and 1. Okay, so we get this, and we chuck it in here. Okay, so we've got a y value of 1, a x value of 7. So therefore 7, that's our y value, equals negative 2 times our x value. Oh dear. Our x value is 7, our y value though is 1. Negative 2, our x value is 7, plus c. And all we need to do is solve this. So we've got 1 equals negative 14 plus c. And then we're going to add 14 to both sides and get 15 equals c. So now we know, therefore, we have y equals negative 2x plus 15. Okay, and that's how we find it when we don't have that x equals 0 on there. Sorry for a couple little mistakes there. I hope that you're able to sort of clear that up in your notes. So thanks for watching, and please come and see me if there are any issues. There's lots of these different things to practice in your text, and I'll see you at school.